Okay, part 2. So now we have everything set up and we've calibrated. We've got our everything is connected with cables. So from the output, the cable is connected to the test antenna, signal travels out into space through to the receive antenna and back to the input port. So really what the network analyzer is doing, it's sending power out here and it's comparing that signal to what arrives here. So if we've calibrated properly, we're telling the analyzer that what arrives here is equal to what came out here, even though we know it's not. We're saying that is our 0 dB reference. And then what do you think is going to happen when we start to rotate this antenna? Well, I already told you that the maximum gain direction is here, towards the receive antenna. So if we were to rotate the antenna in a different direction, the receive signal should drop. So if we've calibrated for 0 dB like this, then as we go this way, it should drop lower to a negative value. We go back to here, 0, and then it should go to a lower value, like that. So to find the beam width, well, we need to know what the beam width is. What is it? It's the angular range between which you get at least half the maximum signal. So this is the maximum signal. So then we need to rotate until we get to half, and we need to rotate the other way until we get to half. And in between this one and this one, that will be our beam width. So we'll pretend that we're actually doing this, and we say, okay, right now it says 0 dB. Okay, so 0 dB, and then I start rotating. Until, and I'm watching, until the marker gets to -3. Then I note that angle, and then I go back here, back up to 0, and then I go this way until it drops to -3. And then, those are my two angles, and then if I were to take this away, if I were to make this into an angle, whatever this angle is the beam width. And that's how you measure beam width of an antenna with a network analyzer.